then it put its own source file in here, and it made its own. Okay. Yeah, so I remember some way they handled the inputs are. Hey, what's up, Mighty Sandwich? What's the question mark for? Inputs are. Hey, what's up, Mighty Sandwich? What's the question mark for? Oops, we don't want that echo. No, just doing some more coding today. What's up? Yep. I just want to open that. I want to open. Can y'all hear me fine? No audio? What's going on? Just double checking here. What's up, Afro Gundam? How's it going? Just getting started here. No rush. Just getting set up. Think I got everything going the way I want it to. Give me a second here. Okay. Cool. Well, I see a few people's here. Yeah, cool. Thanks for dropping by. All right, we got a few people here, so I guess I'll just start with the planning phase of the stream. Okay, basically just today, I want to see what we didn't do last time. So last time we didn't draw a sprite on screen or talk about fighting game design. Maybe we'll do that today. We'll see. We'll put it on the agenda just in case. But there's other things I want to get to as well. I was thinking about. Okay, before we really get started, I really wanted to talk about like core design principles for the game code. So like, okay, let's make a new document here. Code architecture or something. What is that? How you spell? Oh my God, my brain is messed up. I need some coffee. Okay. So let's just talk about some core principles here, right? The high-level goal of this game is basically just to teach people, like, how would you put together a fighting game. It won't be like, it's gonna be close to as a real-world game. It could be using something like Raylib, right? I'm sure you can release games with Raylib. I'm sure people have, but yeah. But anyway, yeah. So, I mean, the first thing I want people to realize about this project, we're going to be writing the game not in an object-oriented way. So, no OOP. Main reason for that is introducing inheritance or polymorphism leads to more complexity than we actually need. Like you're building out a tree of relationships that may or may not be relevant to what you actually need to do in the game, right? Games are primarily big state machines, right? So basically, you have every position, velocity, if you're talking about physics, of an object, acceleration for a particular instance in time. You're running the code on that data and generating the next instance in time, basically all the positions and everything of all objects and whatever state they're in. And then you're using that to render out a frame. So it's not really so much about the relationships between the types, and honestly, you can spend a lot of time trying to make relationships between different types to make sure, okay, we can only operate on an object that is so-and-so type, it's inheriting from the so-and-so object, and it's implementing so-and-so interface. I hope you get where I'm going there. Basically, you can spend a lot of time on like the code stuff and not what you actually need to do in making a game. So I'm avoiding using OOP. But we still kind of need a core design principle which to structure our code, right? And I'm just going to adopt what is becoming more and more the standard now, which is data oriented. So effectively, we just think about the data we actually need in our game to ultimately generate the next frame, right? And not only that, we have to think about how data is actually handled on the hardware we're developing for. Most hardware now is going to be really bad at handling things like tree structures or graphs. It's much faster to operate on contiguous sequences of data that are right next to each other in memory. So just iterating over an array, right? It's going to be much faster than digging into a linked list. That's the basic idea. But on top of that, I will have no deep structures. So not only data, but also code. And what I mean by that is I don't want deep call trees, right? Once we start having functions calling to functions, which call into functions, it's going to become much harder to track what's actually going on. I want things to be flat, right? That's the basic idea. It just makes things much easier to follow. You can read the code from top to bottom. And kind of following from that, I want to consider pipelining data. So pipelining, right? So basically, we are preparing data in stages that pass to the next stage. Either it's persistent data that it represents the state of of the world, or it is temporary data that's only used for generating, or it's only temporary that's used in another stage. An example of that could be, as far as like animation goes, like you would say generate all the position of all the bones in a skeleton for animation in one stage, and then on the next stage you would actually do the skinning, aka updating all the vertices of the mesh. And the kind of benefit of that too is you can do these other stages that are not necessarily dependent on each other in separate threads. So you could update the skinning of a character while you're maybe in another thread you're calculating UI or something, just like something simple like that. Okay. Of course, we have to be careful of things like introducing latencies, right? Once you start pipelining things, you can get bottlenecks in that pipeline, right? So it's something to be aware of. Or things could accidentally, for example, if you have, well, not even for example, because we are effectively simulating a world state every frame, the next world state on the next frame depends on that previous world frame, right? So it's really easy to introduce latencies. Like if the current state depends on the last state, and depending on where you put it in the pipeline, it's some state change, the visual change may not be represented until a frame later. So you might end up with 1 frame delay or 2 frame delay, depending on how you're doing things. Okay, and is there anything else I wanted to talk about here? Yeah, I think this is primarily what I talk about. We might get back to more of this stuff. Okay. All right, this principles. Anyway, oh, and one more thing, and just like some say general, I'll just write, I don't know, code structure here, maybe basically architecture. So we're gonna split the pipeline into systems. This basically is going to be an implementation of, well, it's going to be somewhat an ECS, basically entity component system, which has become more and more popular because of performance benefits that it has. I'm not going to go too deep into ECS. There's a lot of talks about it, but I haven't decided whether or not I'm going to use a third-party library to just go ahead and use someone else's ECS, or just do something very, very simple, like just a bunch of systems that have access to their own, have their own data they handle just in flat arrays, like in object pools. Oh, that's one other thing. Handles over pointers. So there are a lot of reasons for not using pointers. You can use smart pointers, which keep track of all your objects in your game, but that does have additional overhead, and you can kind of lose track of memory if you like lose those or you forget about certain smart pointers. And of course, just using pointers directly leads to potential exceptions. Actually, I don't know the deal with zig and null pointers. I need a double check on how that works, but yeah. Handles over pointer basically is just effectively going to be indices into arrays for now. We might do something more sophisticated later. But effectively, I don't want to keep even handles around very much. I basically just want them to be temporary tools for accessing the data in our game. And speaking of that, we're going to store data in components. So components are not going to have, this is the C part of ECS, components are not going to have their own behavior. Behavior is all going to be handled by systems. Components might have accessor or convenience functions for it, but the basic idea is it's going to make looking or debugging much easier too, because there's not going to be any like hidden state changes that are taking place behind the scenes in private. in an object like you would have in a traditional like actor model or something, or OOP. Anyway, I think that's it for now. What I want to talk about. I'm not super caffeinated up, so my brain ain't working too fast today. Anyway, just to get back into doing something practical, what else would we have here? Yeah, so let's just draw a sprite on screen, okay? It's going to be something very simple. Or maybe a sprite. Let's not even say a sprite. Let's just say draw a circle. Okay. Now, I'm going to look at code that I developed for this rollback project a while back, just to simplify things a bit. There's already a draw circle function. I guess it's pretty easy to use. Yeah, for now, this is just kind of testing to see if we can get, well, just prototyping with Raylib a bit. We're gonna get some like better. We're gonna get into the design aspect of the code a bit later. There's a lot of errors. I don't know what this is about. Okay. So there's some examples on the GitHub, I believe. Yeah. Okay. Yeah. So they looks like they pull in Raylib into a constant. Well, I'll refer it to that way. Okay. We could do that. I think we're already doing. Yeah, they're just doing RL. Okay, I guess this makes sense. Cool. Yeah. Okay. We'll just draw a circle and see if it works. Just a test. Maroon. Okay. Ball position. Does it take a vector? Is this what's going on? No definition for draw a circle. Really? Okay. Let's try it. Let's see. Oh, huh. Maybe it doesn't. It's not picking up the stuff. Oh, let's give it a shot. Oh, I don't have ball position, obviously. Oops. Yeah, I need to look at the implementation of this. Okay, let's just see what it is in C++. Looks like it's just 2 coordinates. Is that going to work? Let's just say, I don't know. I really wish we can get the signature of this function popping up. Yeah. Okay, we're going to have to start looking at the code, I guess. So we don't have a draw. Really? We don't have a draw. We don't even have that available to us, a draw circle? Or is it in other parts of it? It's there. So it's in the Raylib WA? Okay. So we get center. Okay, so draw circle V was a vector. That makes sense. What do we need to do here? Do we need to import? I don't know. What are they doing here? They didn't just include Raylib and they just get it. So Raylib is a package we prepared in the build, right? Yeah. So we import lib.zig. It's Raylib, and then we set that as a package. It's interesting. How did they set this up though? What is this WA thing? Because it does seem to have the declaration of all the functions. Then we have math too. Do I need to do WA and math? Because right now, oh, so it says using namespace import Raylib WA. Honestly, I don't know what that is. Is there examples out of date? I'm really confused. Where's their build? It's interesting. So they expose draw text directly, but what did they not? Oh, hold on real quick. Is it actually exposed? I'm like this crazy here. Oh, okay, that worked actually. Whoops, I just had the wrong signature. Not signature, sorry, function name. Awesome. Okay, so that's not too bad. So we show that it works, right? We can delete. We'll come back to this. We don't need this for now. Okay, I want to look a little bit at what I did in the rollback demo, netcode demo, because it is also using Raylib, just in C++. Okay, when I say draw sprite, I'm basically going to mean draw circle for now because I'm not going to do anything with image importing at the moment. So let's close all this. We open too many files. Okay. So actually I had a few other things I wanted to do. Let's just get some input working, okay? And let's make a basic game simulation like I did with the netcode demo. That basically involves a world state and updating that world state every frame and reflecting that change on the circle. So add state for okay, let's say add physics state. Let's just say move object to frame. Okay. So we're going to add a basic position, velocity perhaps. Well, for now, this is the position, and we'll update that position each frame, and reflect object position on. Wow, my brain's not working. We need to reflect the object position in the window. Okay. Okay. So basically, we need world state and an update mechanism. So hey, this is where structures become handy. So let's test Zig structures. By the way, a lot of this code I'm gonna end up writing here is gonna delete it because it's just like prototyping, figuring out how we're gonna do things, and then we're gonna do better planning later. Cool. I should have my documentation here somewhere. All right. Where's my struct? Okay. Declare struct. Zig gives no guarantees about order. Okay, that's fine. So basically, this is great. We just got to point. For now, we're just going to, use that. So at the top of our program, we're going to say game object, right? And we're just going to have these two variables. We don't want to F32, we want I32. I'm going to get back into that. Oh, that reminds me. I'm going to go back for code architecture. Another principle is, let's see. So this goes back a little bit. Hey, what's Urbis Wolf? What's going on? Just trying to read what you wrote here. I mean, you don't need classes, right? You can write. I mean, games have been written in assembly and C for decades. Perfectly fine without classes. But to your point, UI tends to be, it's a good, suitable for object-oriented, I'll say it that way, because UI ends up being something that you often you want to put into a tree structure, right? I don't know if that necessarily means we want classes inheritance, but it means we do, for something like that, we would want to have a tree structure. For much of the game, I don't want to have that. Searching down a tree structure can be kind of expensive as well. Not only because of the search algorithm itself, but also the cache coherence problem, right? Like pulling things into cache and excising data that's there that we still need and stuff like that. So yeah. Anyway, I'll get more on that when I'm actually if I end up doing that kind of work for a UI. I don't think we're gonna do much UI work on this anyway. So. So the way this is going to be handled is we're going to have a set of components, and objects will be effectively, if you want to think of a classical object, they're going to be there's going to be a relationship between a set of components that would reflect in the object state, right? Each system is going to operate on like one or more components, and those components, for the most part, hopefully, those components for most systems will be read-only, right? And I want to be very explicit about that. And I think it's more a deep topic that I want to get into at some point. But today, I want to move on a little bit and just get this basic game simulation going. Okay. So we do have the game object here. And how would we instance the game object? So how do we instance that? We do, what is a init? Is init a function they define? Oh, it is. So that's interesting. So you can make an init function. I guess there isn't a particular constructor in Zig. But we're trying to keep plain old data, so I do want to do something like this. This is what I want to do. Okay. So at the beginning of our game, we're going to initialize the first frame, the initial state of our object. Okay. It won't be a point, obviously. It's going to be a game object. And just say test object real quick. And it's not float, so we're going to start at, let's just say we're going to start at position, I don't know, 200, 200 or something. Okay. And then, instead of drawing this, we're going to draw X and Y. Okay. And just to show that it reflects see if that works. Okay, it looks like, let's just update the position to see if that is if there is a change. So it was up in the top left, and we'll see if it moves to the bottom right. Okay, well, down here, I guess. Cool. We don't need that. So we have a state for the object that is reflected on screen, right? We're drawing, we kind of decoupled the drawing from the game part at this point. Just a very simple example of doing that. Okay, so now we just need the game simulation, right? So each frame, so each iteration of the while loop will update the state of the object. For now, let's just make it a simple move, and then we're going to add input later so we can control the position. So for now, so let's just say game simulation here. And do we have blocks in Zig like this? I'm not sure. I'm going to give it a shot though. Let's see. Or wait, let's just check that real quick. Does Zig have blocks? Like, blocks. It does have blocks. And you can just do that. Okay. You can return value from blocks. That's cool. Oh, wow. You can label it. Interesting. Huh. Great. Okay. So we're going to like isolate the simulation. That's another principle I need to write down. Not plenty. So if we don't isolate the code for our game simulation, it'd be easy to introduce side effects or influences from outside code, which would break determinism. That's something I'll talk about more later, though. Okay. All right. Going back, we want to get our test object. Can we just change this directly? Let's just move it 1 pixel at a time. Right. Let's see if that works. That does not work. Error. What did we do wrong? What kind of error is this? Can I assign to a constant? So this is it? Oh, it is a const. That's right. Cool. Do we just do var instead? Is that how that works? Yeah, I mean, a big part of this coding is that so we can support determinism. Okay, cool. Yeah, so it's moving. So we got the game simulation working now, right? Just in the most basic way, right? Only updating one variable per frame. And in this way, this variable depends on the value of this variable the last frame, right? So the next frame that we generate depends on the last frame. Okay. Now, just to test it, I want to get input working, and so we have a controllable object on screen, right? So I'm just going to look at a little bit back at my C code that I have here. So we're using isGamePad down. I guess I'll set up a gamepad. I do have my controller set up. Okay. And honestly, I'm just going to copy this code real quick, and I'm going to modify a little bit. Hopefully it will just kind of work. That's, again, this is from my netcode example. I probably and I'm going to move this simulation up a little bit real quick. Yeah, I'm going to get rid of this, because this is the example code it came with. Okay. I'm going to put this in here just for a second temporarily, then move this up. And then we put the game simulation after input, because we want the change in the object position to be reflected this frame. Okay, so we're going to port some of the C code to Zig, I guess. So okay, so we need this. Hopefully we have that is window. Okay, hopefully that works. And what is the Boolean operation in Zig? I need to look at this. I don't know what Zig's, not Boolean, sorry. Bitwise, not bit. Okay, Boolean. Again, coffee. What are Boolean operators? Okay. Or. What? Oh no, operand has and in it. There should be an and, right? This is a bitwise and. I don't want the bitwise and. Wait, why isn't Why is there an or? Wait. This is not... This is merging. Okay. What? Oh. So it's just and? Oops. Sorry. Just do we type and? Okay. This is a keyword. Cool. That's easy enough. And then we need to update this code here for pulling our gamepad. So at the moment, I don't have anything like this enum stuff. So I'm just going to comment this out. We'll come back to it here in a bit. I'm going to kind of shortcut a lot of this work because I did the basic stuff for my other example. If you want to go look at those videos, you can step by step, you can check those out. But anyway, yeah, for now, I just want to see if, okay, so let's just add a new Boolean, okay? So do we have var bool, say var bool, does this work? Oh no, we have the format's like this. Var pressing up, let's see, right equals, and I think we could do like bool, right? Equals false. And then I'm going to do things differently in a bit, but this is just kind of initial steps here. I believe we do put the type after the variable name. Okay. So let's go equals true here. To keep things simple, and then we'll add a condition if pressing left, we'll subtract one. We'll subtract 1 from position, and if we'll add 1. Oops. And let's just make it L. Is there else if? Just to test that. Okay. Okay. Second run. Kind of my strategy here for learning Zig is to type use what I know from C, and if it has an error or mistake, I want to see what the differences are. So, can I assign to a constant? What? I thought did I undo that? No, it should be a huh? Hold on real quick. Is there like a context or this becomes a constant or something? What does this work? But why is this giving me an error here? Hold on. Okay. Oh, sorry. So maybe that's just throwing something off. Okay. We need to... How are these enums defined? I really want to know about that. That's actually a good thing to look up. Would it be in here? Okay. Hold on. Oh, we don't even have gamepad in the gamepad. Oh, is gamepad button down and would be a mouse button. Okay. Let's go to, can we go to the definition of this? Oh, what? Okay. I experienced this before. There is an error in this code, like, oops. Yeah. So is gamepad button down uses the enum mouse button. It's not a mouse. I had to fix this before. I forgot about this. Yeah, so it should be game button actually. So all these gamepad things should be game button. to keep that in mind. Okay. That's actually something. I'm surprised nobody's fixed that at this point. That's really strange. Okay. Anyway, yeah, we should get. So, hopefully the names will. Is this how enums are used? I'm not sure. I'm just going to assume it is for now. Go back to here. It is giving me an error here. What does this mean? Someone declared gamepad button left face up. So did we not have this one? Left face gamepad button. Okay, we're gonna have to go look at enums because I think I'm not doing something right. Enum. So we have enum. Is this? It should be a dot. The dot syntax should be it. So what's going on here? I don't know. Let's just give it a shot. See what's going on. What error are we gonna get? Okay, we did get an error. Hold on. What was the error? Oh, gamepad button down is not declared. Oh, because it's part of the. Got it. Because it's not a global. Does that work? Is there a is this a submodule or something? I'm really confused. It should be part of RL, right? I don't understand quite why that wouldn't work. Okay. So, okay, got it. I'm so used to the C way of doing things, right? This global enums and I'll be right back. I'm gonna get some water. We're getting an error? Okay, I'm gonna fix this first. Use of uncleared game. Really? 195? Wait. Oh. That's in the code I changed. Okay. Wait, is this not exposed? Hold on. Hold on. No. Wait. So I'm a bit confused. So it's exposed because it's pub, right? This is also exposed in the same way, right? Unless there's some other thing I'm not aware of. Okay. Oh, wait. What? No, it's the same thing. So what's going on here? Do I have to import it specifically or something? Oh. Strange. I wonder why they didn't do this. Got it. It's kind of strange. I would think a game library, the first thing you would test is the gamepad. Well, anyway, let me give it a shot. Okay, so left makes it go left, but it stopped. So where's the bug in our code? Let's do it again. Just to make sure, because my pad was not plugged in when I started it. So left goes left, and it keeps going. So what's wrong with my code? Pressing left, bool equals false. Pressing right, okay. Oh, got it. Wait, no. Left is true. Pressing right is true. If pressing left, do this. So why does it keep moving? Oh. Yeah, that's why. It's outside the while loop. It needs to be inside the while loop because we want it to refresh back to false every frame. Okay. Okay, cool. Pressing left moves it left. Pressing right moves it right. And there we have basically input controlling game state. The game state being updated per frame, which is being reflected by drawing the circle. Okay. Some basic stuff laid down. We got it working. It was a good use of time because we made these fixes for the library to support the gamepad. Is that something I should do like a pull request on or something? Or has anybody already fixed that? If anybody knows. So you would think you'd want to have gamepad working. Oh yeah, I'm gonna some water. And if anybody has any questions about that stuff, feel free to go ahead. I'm back. So, before we get deep into coding, which I don't really plan to do today, I kind of want to have a longer stream, maybe this weekend, where I start building up the core game structure. I just want to talk about a little bit how I would like put together a fighting game from scratch, right? How we're actually going to pipeline data around. So I'm going to just go back to our code architecture stuff. Okay, I'm just going to say, I'm just going to see, move this here. And we're going to have to start like mapping out how I want to pipeline things. I mentioned before I want things to be very flat, okay? So of course I'm gonna start writing pseudocode because it's kind of the way I like to do it. So basically we're gonna have our main game loop, and within the game loop, we're going to have, well, obviously we're gonna have system initialization. Well, say platform initialization stuff at the start. And then the game loop, and we're going to split things into stages, right? So the main stage is, because we're going to be writing a deterministic fighting game, we need to store, sorry, I got a little ahead of myself. I want this to support rollbacks right away, which is basically deterministic resimulation. In order to resimulate, we need to store previous game state. So we need to support that, right? So, of course, we're going to have game simulation. That's going to be a key aspect of it. This is where we update the game state. And we'll have rendering or drawing after that, right? We want the state change to be reflected immediately this frame, or as soon as possible, depending on the pipeline, right? Those are core things. But before game simulation, we need to do input handling so that we don't get a frame delay in input, right? So input handling is going to be broken down a little bit. But if we put it like, say, after this means our input is going to be read after the game simulation, which means it will be used the next frame, and we would have a delay of one frame in our additional delay of one frame in our game. We don't want that. We want to be able to see it, the input being reflected in on the screen as soon as possible, right? And what you see here is kind of the basic pipelining, right? Input is read here, processed in game simulation. The game simulation generates a state, and that state is used to generate, draw what's on screen. So that's the basic pipelining, doing things in stages. Okay. Because we're going to be using deterministic resimulation or rollbacks, we need to store game state after we simulate it. That's very important. And if we do if we want to support netcode, we're going to want to do network update after input handling. If we do it before input handling, you might introduce an additional frame of delay that you don't want, because you want it to send out that input to the client as soon as possible. Okay. Hope that makes sense. Now we're going to break down game simulation into other stages as well, right? So game simulation, the first thing we're actually going to do, at least for now, is command buffer. So the command buffer is going to take inputs that we pulled here and turn them into commands that we use in the game, such as walk forward, walk back, punch, etc., etc. And also handle things like special move inputs, such as shuriken, hadoken kind of stuff, you know, quarter circle forward, quarter circle back. Okay. And from there, we could stage things in a lot of different ways, right? I haven't gotten deep into it at this point, but we're going to need we need a character state machine. So right now it's a little, I'm kind of fluffing over the details right now because the state machine might be updated in stages itself instead of at one update, but for now I'm going to leave it here and we're going to get into it more. I'm actually going to put brackets around here so we know it's this part of this. This is just kind of my pseudocode. Don't worry too much about the syntax. So we're going to have collision updates, but in fighting games there's multiple kind of collisions, right? There's like pushed collisions, so one player pushing another. There is the wall collision, so when you're bumping up against the ends of the stages. And there's also collision that happens that moves the camera, right? So, or even the characters can be blocked by the camera extends, right? The walls of the camera, if you have one player on this side, you cannot go beyond the left side of the screen in most fighting games. You can pull out potentially, you know, and not have any camera walls. That's the simplest thing to do. But for this, we'll have walls. So at some point, we'll need a wall update. So the wall update will handle the camera, the bounds, right? Or maybe we could say it, yeah, we'll say a wall update for now as part of the staging. We'll need a camera, well, so actually first, game camera. So the game camera is something that gets mapped onto the actual camera that shows what's on, shows in the game, what actually gets rendered on screen. And the game camera is what's going to drive our walls, right? Okay. And after all that, we'll have to handle wall collision. So we'll have to handle the wall collision after all that stuff is updated, right? But the thing is, we need to know if the character's new position is causing a collision. So that has to happen before, right? So all this stuff about putting things into stages, it's really important to consider when things actually happen, right? Otherwise, again, you'll get maybe one frame of a character appearing off screen when they shouldn't be, right? So if you have ever have constraints on a system, you need those constraints to happen at the very end. So we have to handle the wall collision at the end, okay? The wall update can handle, maybe it can be independent, but actually in the case of this game, wall position is handled by where the camera is, and where the camera is driven by where the characters are. So the character state machine update being before the camera is great because we'll say update all the positions and stuff here. I want to split this up a little bit, actually. So I want to split it up into an action state machine update and character. For now, let's say character physics update. Okay. Now this is kind of a tricky thing. We actually might have to pipeline this, split these stages up and to be more granular. So in the character physics update, we'll handle position update. Okay, we'll handle things like handle velocity. Let's say position, velocity, acceleration. So, and here we'll say take the acceleration and then update the velocity, and take the velocity and update the position. And that the order there matters as well, but we'll get into that at another point. The tricky thing is what do you do first, right? The action state machine update is like what we're updating, what move the character currently is in. So you would say take a command. Okay, yeah. So let's say generate okay, I might write something better here later. But so basically the idea is we'll take player's input here, generate the commands, and then within the action state machine, if we say press light punch, then we want the character to transition into the light punch animation along with all the other properties of that move, right? And then actually, this part gets tricky when you talk about a 3D fighting game because animations end up being very complicated things. In a 2D fighting game, it's just a sprite basically being drawn on screen, so it's just an index into a list of sprites in general, right? You might have things broken down a different way, but that's the basic idea. You have an animation and then a frame within an animation. So you could just easily render that by looking at, say, the game state. So what we need to do after the state machine is updated, and we could make it part of it, but here I'm going to say animation system update. Yeah, so we're going to update the animation system after we handle the action state machine. That way we can look at the change that occurred here and then update the animation state. I hope that makes sense. We could do it here. We could do it within this stage, and we might end up doing that actually, but there might be some other reason why the animation gets changed, so we want to potentially allow for that. Okay. So those are big parts. So we handle wall collision. We haven't talked about character collision yet, like attack animation, right? So I do want to handle character push collision first before the wall update, because you can actually push characters around in most fighting games, right? So that's something that needs to happen before the wall collision. Now the tricky thing is do we want the camera? We not necessarily care to be this granular, but do we want the camera to update before or after the push collision? That's important, I guess, or maybe it's not important, but it does affect ultimately where the camera ends up, right? Because if we put the character push collision before camera update, it's going to be, say you have two characters moving, one is pushed a little bit, so the camera's going to try to center, right, between those characters. If you update the camera before that, then it won't be shifted just a little bit, right? So I don't know what we want to do there. I forget exactly what I do on my games. So we'll go back to that at some point, potentially. It may not even be noticeable because it's going to be affected. It's going to be updated the next frame either way. So it's just only going to be like these things we can consider all over the place, but it will introduce a 1 frame lag on the position of the camera, right? There can be effects there, but the thing we have to consider though is even if we do that, the wall might prevent the character from moving in the first place, so the camera can't move a certain distance, right? So we have bounds on the camera's position as well, but I think we're going to handle it in here. Anyway, we'll get back to that. There's a lot of subtle nuances to handle how you do this stuff in a fighting game. Okay, so I've not talked about attack collision, right? So this is a tricky part. Like, do we put the attack collision before or after the character action state machine? Let's put it this way. Say if I handle a collision here, and it sounds great at first, right? Like, okay, let's handle a collision here, and then within the action state machine, we can update the current state of. Sorry, we can update the current state of the current state of the character to be like, oh, going into hit reaction, right? But there's a nuance there, right? Because you have this push collision going on over here, which is updating the position. You kind of want, things overlapping to be clear to the player. If something that looked like it wasn't going to hit, if something looks like it's going to hit because of the right position on screen to the player, and if it whiffs, for example, if you're walking back into the wall and the wall update hasn't happened yet, so the game, if it does a collision check here, it's going to think that the attack didn't hit. But in reality, the character had been pushed. Now, it's still going to hit them a frame later potentially, but it does introduce a frame, the effects of the wall update will introduce a 1 frame lag into the collision system because of that. And it might be noticeable to a player, may not be that noticeable, but it's going to feel a little weird potentially. And that's just something you have to take in consideration. So for now, we're just going to say what we're going to do is we're actually going to kind of split up. And this is going to be a common theme. Is we're going to take a stage and split it up into multiple stages to remove latency from the system, from the game. So this state machine update is just going to handle input commands or what the player is doing or the natural state transitions that the state machine is driving. And we're going to introduce a reaction system. So this is going to it's going to force, say, a player into a reaction state. So transitions characters into reaction. So that we'll see it this frame, right? We'll see a change in their state this frame immediately. We still haven't put the collision in though. So we'll put it right ahead of it. We might change the position in the pipeline later, but for now we're just going to put character attack collision here. So okay. So this is the basic pipeline for the game simulation. Again, it might change, and we still have a lot to do here. Things like we'll have to update the visual camera update. This will have to, we'll have to do this somewhere, probably here. And I'll talk more about the the display or display camera, visual camera, whatever you want to do, call it. It's what ultimately determines what gets rendered on screen, and it will affect things like culling and stuff like that. But we probably won't even get into that for this project. It's way outside the scope of what I really want to do. Okay, and there's a lot more to do here, but I think I'm gonna call it a stream. It's been about an hour, and once we start diving into this code, maybe I'm gonna do it this weekend. I might do a 2-hour stream or something like that, just so that we can get a good chunk done on the overall architecture of the game. So yeah, we did this stuff, so I was gonna check it off. We didn't add a physics state actually, so we had a basic physics state. So we did that, and we didn't do any fighting game design chatting this time. But what did we do? Discussed game code architecture. Okay, done. Sweet. Hey, what's up, 16-bit? Yeah, so yeah, that's it for what I want to talk about for today. Next time, I'm going to get into talking about the actual data structure we're going to use for the game simulation, for characters, for projectiles, things like that. And I might just write that down real quick. Data structure. Then I might talk about projectiles. Maybe we'll talk about the character state machine system, so the character action state machine. Maybe animation, I don't know, at some point we're going to handle it. Whoops. Okay. But yeah, that's basically it for me. If anybody has any last questions they want to ask, go ahead. Or want me to elaborate on anything we've done here. Yeah, I hope this was informative in some way. I know we didn't get anything amazing or exciting done. I know sometimes it feels great to just jump in and code a bunch of stuff, but it's good to have a direction, I think. Yeah. Oh. How's it going, Johnny Marler? Thanks for dropping by. Unfortunately, we're finishing up the stream here, but recently I've been doing this about every day or every other day. So yeah, thanks for welcoming me to the Zig community. I'm not really that involved as far as like a Zig person. I'm just more of a game developer who wants to use this as kind of a instructional tool, and I think Zig is a good language for doing that. That's why I'm using it. So. But anywho, I gotta get to work, and I hope you all have a good evening. Oh, any reason you didn't use Rust? I did look into Rust a little bit, but it just wasn't. I just couldn't get into it, I guess. There's a lot of memory management stuff you have to understand about it that's very different than C, and I just wanted something very close to C, if it makes sense. It's something I'm very familiar with, so I would be less comfortable teaching or explaining this kind of stuff in a language like Rust. Well, it's good to hear, Afro Gundam. Thanks for dropping by. Well, y'all, yeah, I got to get going, so thanks for the questions. Thanks for participating and being active in the chat. It means a lot to me. And yeah, I hope to see you around very soon. If you're out in the US, good night. And if you're in Europe, I guess, good morning. Very early morning. Anyway, hope to see y'all again very soon. Peace out.